Welcome to Sustainability Now, technologies and paradigms to shape a world that works. Designed for everyone interested in responsible stewardship of the planet, covering topics related to food, energy, housing, water, waste, health, economics, and consciousness. Welcome to your community, Sustainability Now, with your host, Scott Billy.
Hi, everybody. I'm Scott Billy. Today, I'll be your host on Sustainability Now, and I'm proud and honored to bring you Tim Tan of Affordable Abodes. Tim brings 25 years of experience from the construction industry to bringing affordable housing to lower income workers in Malaysia. 25 years ago, he worked and founded a company called Kenafcrete, a construction adhesive and tile company. He's also the director of TBN Asia and the founder and director of the Dry Mix Mortar Association. Well, welcome, Tim.
Greetings, Scott, and thanks for having me on the show. I've been following your program, Sustainability Now, for quite a number of months or years even now, and very excited to be able to share with you what we're doing out here in Southeast Asia.
That's great. Thank you very much.
Thank you.
Can you give me a little bit of a background of Affordable Abodes and how you got started?
Sure, yeah. Well, about 2015, I left Kenafcrete management in Singapore and decided to do some mission work, amongst the poor in Cambodia and Indonesia, and found out that, the severity of lack of good housing was really something which was very challenging for many governments to address. So while I was out there, helping to build schools, churches, and things like that, we discovered that most of the people that we were trying to work with lived in slums. So that really got me thinking. After 20 over years of doing expensive business, we realized that we're really not making much of a dent in the global pandemic situation of the shortage of housing. And I think probably about 15 to 20% of our world's population lives in substandard housing or not even proper housing at all. So that really got me thinking. We do business in a different way. We're taught different things in school, but we're really never taught how to solve the serious problems in things like housing, in things like sanitation, water supply, energy supply. So I got really disillusioned, by doing business that way. So Affordable Abodes, came about when we started looking at different solutions for low-cost housing. And it was through my friend and mentor, Dato Kim Tan, who's a biochemist, that we came across hemp, and then Kenaf later. So we went around the world, looking at hemp technology, hempcrete and things in the UK, in the US and Canada. And I thought, oh, wonderful, I can bring all this stuff back and we can start building it. Well, silly me, guess what? Hemp is illegal here, right?
Yeah, it's
so
still a bit too close of a relationship with its illicit cousin, the cannabis.
Yeah, unfortunately. And it also doesn't grow too well in the tropical belt.
Okay.
So hemp does well in parallel 40 and north, but through a chance, we actually came across Kenaf. And it was not that big, I'm so clever and have a botany background or anything. It's just that I think, it was a miracle that we came across this species. And I looked at it and I said, this is it. We've got to do something with this. So the Kenaf industry in Malaysia has been around for more than 10 years. but they really haven't done very much with it so far.
I know that the Malaysian government has made quite an investment in getting the farmers converted over, right?
Yes, yes. They pumped in tons of, millions of dollars into this business, into farming it, but without looking downstream and, trying to think of what a good application for Kenaf fibers or Kenaf core would be. So then we decided, okay, we'll try and to use the Kenaf core, and did some research in then, and built our first Kenaf block house from field, literally from farm to house. It took us about 6 weeks after harvesting, making the blocks, and then building the house. So that house was built in 2016. We've left it exposed to weather the elements, and it's held up very, very well so far.
So you have no external coating on that, like a plaster of any sort or anything?
No. We left it completely exposed to study the effects of, sun, the rain, the insects, and, what have you. So far it's so good. It's looking very, very, very almost like the original building.
That's great.
Yeah.
And for folks that don't have a background in Kenaf or hemp, let's talk a little bit about the plant structure itself. The stalk is similar. If you think about it like a tree, the core is the wood of the tree, and the fiber is what would be the bark on a tree. So can you describe the process on how you go about separating that all?
Yeah. Well, let me explain a little bit about Kenaf first. Kenaf is actually a hibiscus cannabinus plant. So it's actually a hibiscus plant, which is the national flower of Malaysia, by the way. So we actually use a bioretting process to separate the stem, the core, what we call, from the external, which is the fiber. And that helps to separate it very cleanly. We get very clean fibers, and a very clean core. And from there, you'll dry it. You wash the fibers, with bioretting process to clean them up. And the core, you'll dry that, and you'll chip it up into small chips, maybe chips of about an inch or less. And that's it. That's the raw material that's ready to be used as an aggregate to replace stone and sand, typically, which you would use in concrete. The next step is to get into making the Kenaf blocks. We actually use a binder, a lime binder. It's a hydrated lime. In our case, we were very fortunate to come across a type of waste lime from another industrial process. And so we're completely upcycling both matters. There's 90% of plant core in there, Kenaf plant core, and 10% of lime binder, which comprises the structure of the blocks. In our case, we've gone beyond blocks. We're making prefabricated panels, and with that, we're building, modular housing.
Yeah, that's really an impressive move forward as far as the amount of time it takes to do construction on site. If you're coming into the construction site with prefabricated panels, they just need to be put together. Can you describe that process a little bit?
Yes, sure. We actually can erect the house structure within less than a week. We're talking about a small, low-cost house, so probably about 600, 700, 800 square foot type of house. We have an integrated ground beam foundation. We don't need heavy ground beams, even in soft soil conditions, because the building is so light. We're about a quarter the weight of concrete or brick. So it works very well for soft soil conditions. And with that beam, that steel beam in place, we can install the panels, and the panels are interlocking with the ground beams.
Okay.
So that takes, that process takes altogether about 3 days. The ground beams and putting up the walls, and then comes in, your roofing structure. And then finally, once all that's done, we'll cast the floor slab. We'll put in our Y mesh. Hopefully one day we'll replace the Y mesh completely with Kenaf fiber reinforced concrete and then cast the whole slab. So the walls are really embedded in the concrete.
Right. So that steel is totally encapsulated between concrete on the bottom and the Kenafcrete walls to
That's right.
keep it from being exposed to the elements.
That's right. And then you have a steel portal going around the top, which anchors the roof to the walls. So it's a fairly simple process. Our panels are 10 foot high by 2 feet wide prefab panels. They are steel encased with light gauge steel going all the way around it. So each of those panels, Kenafcrete panels, can withstand a load of 5 tons,
Nice.
5 metric tons. So technically, we could build, 2.5 story building structures with that type of strength capabilities. The reason why we don't do large wall panels, I've seen very large wall panels being built in, for building houses in the UK. They're building up to 4 meters wide and 4 meters high. The reason why we don't do that is because generally we're trying to adapt our system for building in the kampongs, in the villages. And to get into those areas, you don't have much of a road. Right. At the most, you could put in a pickup or a small little truck. And there's no craneage, there's no lifting gear that could, go in there. So everything's, done quite manually, quite low cost in that sense. But we could, possibly build just about anywhere we wanted to in that case.
Right.
So it's
nimble that way. You don't rely on heavy construction equipment with cranes and everything.
Yes, that's right. Yeah.
The example that comes to mind for me personally, I used to build log houses, and we put them on precast concrete foundations. So we would have the trucks show up they were literally the whole length of the wall, and they would bring them in with a crane, and it took 4 hours to build the entire foundation, which was really cool. But if you don't have a place where you can bring that kind of equipment in, it's really not an option for you.
Yes, that's right. Yeah.
Yeah.
So, we sometimes we're looking at building in very remote locations, even for the people that, the hill tribes, for example. So they also need something very light, because they're generally built on a very sloping conditions. And they need to make sure that nothing slides off into the valley.
Right.
So there's different applications. Of course, out here in Singapore or even in many parts of urban Malaysia, we have high-rise construction, going up 40, 50, 60 stories. So that also we have not done yet, but we intend to address the problems that have been associated by using lightweight, high-strength material rather than heavy concrete, which actually ends up increasing the cost because you need heavier foundations and you need heavier structural supports. So I think, the world could benefit a lot. It's not just our technology. There's a lot of good technology out there that's, lightweight, high strength. But in our case, we like to think we're a little bit more sustainable than they are, because we're not, exhausting resources like sand and cement and limestone, you know.
Right. It seems
Yeah.
like there's probably a future possibility for some hybrid solution where you've got the high-rise structure and then integrating the Kenafcrete panels to, to take the non-load bearing, pieces of the construction.
Yes, that's right. Yeah.
Great. Have you had any issues with the steel and the lime binder? Because I know that lime sometimes can be corrosive, whether it would rust the steel out at all?
So far, so good. The steel we use is galvanized steel. And both elements are, high, in terms of alkalinity. So it's worked out quite well. We don't use a very high concentration of lime. Like I said, it's only, by volume, only 10% of lime.
Right.
So I think, of course, we are looking at even using geo cements, things like granulated blast furnace slag, fly ash, But it's really a question of availability. So if we're near a source, then that's fine. But in our case, even things like that have to be shipped in, so it doesn't add up to my green equation, so to speak.
Carbon footprint goes right back up, and all the benefits you've gotten by sequestering the carbon with the Kenaf growing is outweighed if you're shipping stuff around too much.
That's right. Yeah.
Really, you customize the solution to the location and what materials are available there. That's
correct. Yeah. And so that also helps to keep the cost down at the same time.
Sure.
Yeah.
Have you looked into using either timber or bamboo or anything else in place of the steel?
Yes, sure. Well, ultimately, we'd like to produce Kenaf fiber supports, FRP struts, for example, studs and things like that. When we have that technology, and actually, I've been speaking with our friend Sean Steed, the bio-epoxy man. We're working out, some potential projects together with that to make Kenaf FRPs.
That sounds very intriguing to me, and get the steel out of the equation would bring your green factor way through.
Definitely, yeah. And bamboo, where
sort of chime in for a second with a little bit about Sean. We have interviewed Sean before, so if you're interested in checking that out, there go to sustainabilitynow.global and look for the bio-epoxy interview. And what he's doing is he's taking the waste glycerin from biodiesel production and turning it into a plant-based epoxy with no volatile compound, VOCs, and totally free of carcinogens. And it's a great circular economy model that he's got going on. And it's right around the corner from you too. He's in Johor putting up his pilot plant right now. So it could be a very, very convenient circumstance for you guys.
Yes, definitely. And Sean's a great guy.
Definitely doing really good work.
Yes,
And,
yes.
Since I mentioned sustainabilitynow.global, I wanted to point out that everything that we talk about in the interview today, any resources or links that we bring up will be available. Just go to the website and you can get access to all of that there.
And Scott, you mentioned about bamboo. We are actually working on a project with the Philippines. Hilti Foundation. Hilti is a big construction tool manufacturer. So they've set up a foundation in southern Philippines to help people build or rebuild their communities after the typhoons have wiped them out.
Right.
And these guys have sort of mastered the technology to use bamboo structure to do these houses that can withstand 200-kilometer typhoon conditions. It's quite impressive. So what they do with that is they plaster the external of the building with cement mortar. And so after we met them, they were keen to look at replacing the cement mortar with our Kenafcrete technology.
Oh, that's
So
great.
that would be something wonderful if we could push that through.
Mm-hmm.
So where structural bamboo is available, then I think that's the perfect solution, right?
Right.
Yeah.
But it's not indigenous to Malaysia?
It is in certain parts up way up north. Unfortunately, much of Malaysia has been cleared
Right.
for plantation purposes.
Mm-hmm.
I won't name names, but I guess for economic development, it is important to have some plantations, but hopefully they can improve on their sustainability to do so, and also combine planting of other types of crops like bamboo and Kenaf. So
Right.
that's something we're working with also the palm oil plantation people, or rather oil palm plantation, commercial stakeholders, to introduce the idea of planting Kenaf, and even bamboo. Bamboo can do well under certain conditions. It needs a lot of water.
Right.
Unlike Kenaf does well in open fields. It's a good alternative crop to crops that are not doing well, because it doesn't require so much attention and care. It's a very hardy plant. Within 4 months from seeding, it matures, and it grows up to 4 meters high, and you can produce a lot more biomass on a given area compared to trees, planting trees in a very short time.
In your region, you get it's year-round growing, so you get three
Yes.
harvests a year, basically.
Yes, that's right. Well, technically 2.4 harvests. I mean, we've got to prepare the land, and
I imagine getting a crop rotation would probably be the best way, so that you're not constantly doing the same thing that some of the other industries are doing, where you're planting and clear cutting, but let it go fallow for a year and put the cover crops in, so you can replenish the soil and all of that.
Yeah, actually, we also work with some paddy farmers, and paddy is a very exhaustive soil exhaustive crop, whereas Kenaf is to a certain degree nitrogen fixing.
Mm-hmm.
So it does improve the soil, especially the way we do it, because we compost all our leaves and shoots after we harvest, and we can put that compost back into the field. Now, one thing I want to mention about paddy, because of climate change, and this is very high, I'm sure on your agenda as well, a lot of crops are failing, such as paddy. Paddy,
on our side of the world, paddy is rice paddies, right?
Rice paddy, yeah. Thank you. So, and I think 80% of the world eats rice, actually. So it's a very, very important crop, but unfortunately, because of climate change, during the harvest season, when the climate's supposed to be dry, sometimes it rains, and it rains very heavily, so that spoils the grain right before they're able to harvest it. So we're also coming in now as an alternative crop. Kenaf is being used as an alternative crop to help improve the income of the farmers who are suffering from crop losses.
Right.
And we're having tremendous problems with desertification of farmlands all over the world now. So we've got to think differently. Kenaf can be eaten. We can turn the leaves and shoots into very highly nutritious food crops. They contain about 30% of protein. So it's nutritious.
A better food source than the rice that it could replace.
It could be, yes.
Yeah.
It could be.
And it grows in the same fields. I guess you have to drain the paddies in order to plant the Kenaf there, right?
Yeah. Well, most of the fields are actually flooded fields. You know, they have to be, you know, mechanically flooded. There's really a huge problem with water, as we know. You know, they either get too much of it or too little of it.
Right.
So
I was going to say that would be a great solution to plant, you know, something like Kenaf that isn't so water intensive to save that water for other purposes like drinking.
yeah, that's right. And Kenaf also can do quite well even in flooded conditions.
Okay.
So it's a tough plant. It's a very hardy, tough plant.
Now, how does it do? Like you mentioned, the rainy season at harvest time was killing off the rice and spoiling the grain. I know the same thing happens with hemp. If you have rains at the wrong time, it can create mold when you're trying to dry your hemp and do the retting process. Does Kenaf work a little better? Is it more resistant to that heavy raining at the end?
Well, yes, I think it's all right. But what we do is we take the stems and we quickly process them while they're still green. We don't let them dry out. I think what they do with hemp is they actually let it field ret.
In some cases, yeah.
Retting or rotting. Rotting is not good. It actually introduces a lot of degradation of the quality of the core and the fiber. So by using microbes to help quickly process the fibers, we maintain the quality of the core and the fiber. So we're talking about, you know, within 8 hours, we're able to peel the fibers off the stem, you know, instead of a few weeks.
Right.
And that also improves the productivity for the farmers. You know, there's not many people who like to do farming nowadays out here, unfortunately. Everybody's running to city jobs, but you know, with COVID, the pandemic, I think they're gonna think quite differently about, you know, their future.
Yeah, I think that there's going to be as we start to envision what the new normal looks like, there's going to be a big movement to local economies and self-sufficiency, as opposed to relying on resources and food being shipped all over the world.
Yes, that's right. So it's really about, you know, agro-technology. I think food sustainability, agro-technology, you know, and how we can engage the next generation to do this, you know, to fix the problems I created, right? I always say. Yeah.
Yeah, definitely. Well, you had mentioned that the Malaysian government was backing Kenaf agriculture, but I guess the next step will be getting into more industrial processes, because I know that, you know, the same thing's happening here in the U.S. with the hemp rush. Everybody's growing hemp, and a lot of people are sitting on it now because they grew it last year and they couldn't find anybody to process it for them. You know, the decorticators that are, you know, crushing the herd,
yeah,
and processing the fiber. You know, that's the next big investment that I see happening here. Is a similar thing happening in Malaysia?
Well, Malaysia has adopted sort of, you know, different approach. They've had the advantage of so many years of, you know, studying hemp and studying Kenaf and jute. So they've actually benefited from adopting technologies from all over the world. Mm-hmm. So from Italy, there is a mechanical retting machine that helps to decorticate the fibers from the core. And that machine is a very small, you know, I mean, you can even put it on the back of a pickup truck and do it in the field. So what I've seen, you know, in other parts of Europe, of course, you know, machines that cost millions of dollars and are not mobile. So for us, because the plantations are spread out over many different locations, we need to have a mobile system. And so this little machine that originally came from Italy has now been replicated in a very large country in Asia. I won't name the name, but I'm sure you'll guess. I mean, you know, there's plenty of. It's not a complicated machine. It's very inexpensive, and so you know, just about every farmer has access to one.
That's great. So rather than shipping the plant matter to the processing, you bring the processing local right onto your farm and take care of it yourself. And now you have upgraded your product, and you're not just producing biomass anymore, you're producing a finished product.
Absolutely right. Yeah.
Yeah.
Also, the process for cleaning the fibers, the retting process, you know, produces a lot of wastewater.
Mm-hmm.
And that wastewater is actually, well, if we don't treat it, it becomes pollution. You
Right.
know, if we treat it right, it becomes nutrient, and that nutrient can go back into the field. So it's better to process the fibers on site or near the fields, and of course the core and all the processed material can be taken to a you know, factory to be further you know, processed into suitable building materials or FRP type materials.
Yeah, I know that the wastewater became a really big issue in the Eastern European countries with the hemp fiber production for textiles. A lot of them wound up getting shut down because they couldn't afford to treat the water when they were done. They're doing the cottonization, so it's a much heavier process than keeping the long fibers for more like a linen kind of product.
Yes, that's right. You know, unfortunately, in other parts of the world, you know, where they don't have access to the biotechnology, Kenaf, jute, and hemp are just dumped in the river to do water retting.
Mm-hmm.
You know, and that is extremely bad for the, you know,
For the river.
river, yeah, the entire ecosystem in the river gets messed up.
Right.
And that obviously flows out into the sea and you know, destroys the marine life as well.
Right.
So, you know, companies have to take that responsibility to make sure that this doesn't happen. Yeah. Some are using even worse solutions like sulfuric acid. You know, that is one of the worst things you could handle.
Yeah. And I'm sure the disposal processes are not what they should be.
No, definitely not. You know, the sea becomes our dumping ground, right?
Mm-hmm.
Unfortunately. And we know that all that trash ends up in our body at the end of the day.
Right.
You know?
Absolutely. Yeah. Well, it's great to see that you've got a solution that's skirting all of those toxic chemicals, and it's keeping it on the environmentally safe side. Can you describe any projects that you've got coming up in the near future and ways that some of our listeners could either get involved or support you?
Yeah, definitely. We're looking at engaging some housing projects in Malaysia. We're also trying to expand into Indonesia, where there's an even greater demand for housing. Malaysia needs about 1 million low-cost houses. Indonesia needs 20 million.
Wow.
You know, it'll take me a few more generations to solve that one. But you know, the
single unit houses or like multi-family housing?
Both. I think we need to look at both solutions. And actually, my biggest interest would be in redeveloping urban slums. Mm-hmm. And we could do that by clearing up the slums and you know, building low-rise apartments. I think, you know, 4 or 5 story walk-up type mm-hmm. apartments would be a very good solution for that. So that allows people, you know, to stay close to their jobs. And then, of course, these slums are you know, massive. They're huge dumping grounds all over, you know, the big cities. And, you know, people are living off this trash, basically. And,
right.
living and dying, unfortunately.
Mhm.
So, you know, we hope to engage the governments to participate in developing this technology in their own countries.
That's great. So bring a higher quality of life and better sanitation, you know, better insulated walls and ceilings so that the indoor quality is far improved over what they're doing now.
Yeah. We're also looking at building other, you know, social impact type buildings like clinics, hospitals, medical facilities, schools especially. I think I dream every day about, you know, building a Kenaf University one day. You know.
Well, it's a way of giving people useful employment as well. To the effort you're talking about to replace the slums with Kenafcrete housing, that's going to take a lot of labor to make that happen. So there's a big opportunity to, you know, reschool and teach people trades.
Absolutely, yes. And that's just, you know, using the waste part of the plant, right? We haven't talked about the Kenaf fiber yet. So
Right.
my next process is to look at using Kenaf fiber to turn it into fiber, you know, Kenaf fiber reinforced plastics. And of course, even in housing, it would be very useful to make things like roofing sheets, to make furniture, door, window frames. Many things could be developed from this technology. By far, the biggest application for Kenaf fibers right now is the automotive and the aerospace industry. Sure. They're using that to build the interior components of all these transportation devices. So that makes the vehicle lighter. It also makes the vehicle much healthier to use because you're cutting down on the plastics.
Right.
Yeah.
Less off gas inside.
Yeah. So those are the two areas, I guess, that we're looking into to expand into is really, you know, to do more housing, especially for the urban populations, but also to develop more technologies for Kenaf fiber reinforced plastics.
That's great. So if people want to get involved, what can they do?
Well, call me, write me. I guess we'll be able to post our emails, contacts up there somewhere.
Yeah, that'll all be available on sustainabilitynow.global.
Yeah.
All your contact information there, a link to your Affordable Abodes website and your projects that you've got going on.
Yes, we've got a couple of YouTube videos that you can watch, and of course, we welcome ideas. I mean, we're learning from the community all the time what the needs are. You know, we'd be happy to explore with you any ideas that you might have as well. We are looking for funding. We're looking to scale up our operations across Asia. So we're looking really for funding from strategic partners. I like to call them strategic partners because we want to get people involved, you know, rather than just putting your money down, do something with it, you know, go build. So a strategic partner would be something like a property developer, you know, a manufacturer, concrete manufacturer, of course, you know, it would be an interesting option for you to change what you're doing. And also we welcome academics as well, because we're looking into research and, you know, testing and developing, you know, more technology, both in the agro economy as well as in, you know, in the civil structural designs for buildings, architects, interior designers, you know. These are all our, what I call my partners, you know. They love what we're doing, and they're just hoping that we can produce more stuff for them.
Great. So do you have any resources you could recommend to people that want to learn more, whether it's associations or websites or books you think people should read?
Well, I think by far the most, you know, what do you call it? Literature has been written up on hemp. There's very little done on Kenaf. I guess because, you know, hemp was used in places like France and Germany, where the technology has really gone into the aerospace industry. But they, and also hempcrete was developed, I think, in the UK. So that's a lot of good information out there. As far as Kenaf goes, there's not really anything well written so far.
Are there any international like associations or organizations of people working together to sort of further the industry?
Not really. I think there's a small Kenaf association in the US. They're planting in places like Kentucky. We've got a friend who came to visit us from that area. But really, I think it's a matter of connecting with academics, you know, who have done some research papers, but have not really been able to commercialize things yet. So we need to bring these two worlds together, you know, the commercial world and the academics.
You met our friend Bob Larson. He's based in the central United States, and he's sort of a big Kenaf advocate. We interviewed him a while back, and he's a common visitor for our Thursday night hangouts that we do every Thursday. So he would definitely be a great person for you to meet up with and further each other's knowledge.
Yes, I'd love to invite him out here and, you know, give us a talk and learn from him. I watched his you know, his video webinar online. I think it's, you know, really a matter of getting these professionals together to, you know, really think of solutions, you know, to these problems that we've been creating. But the real issue is scale, always in scaling up. You know, how do we get this stuff available everywhere at a very cost-effective price? You know, so that's where I think the social impact side of things can come in. So we work with, you know, very poor farmers, you know, people who live in the slums. You know, it's not easy. I can tell you most of my team comes from very, very poor backgrounds, you know, but today we have taught them how to farm, how to process and manufacture, and they've all been cross-trained in construction as well. So that, I think, is one avenue, an important avenue to get this technology, you know, off the ground and moving into the masses, while we look at the, you know, so-called higher end of application. I mean, where's all our material going to go now, you know, with the global pandemic? We really need to form this circular economy and do it quickly. We've got to nail down solutions that we can enable farmers to grow their own home, technically, right?
Absolutely. And you solve the global pandemic problem if you keep it right on the farm.
Absolutely.
Grow the material, process the material, build with the material right on your own property.
Absolutely. So the next phase of things I'm doing is to look into modular factories where I can build very small machines, even containerize them, put them in the villages where, for example, a family unit could work together to produce building panels. right? Rather like in our big factory, when a pandemic occurs, we're completely shut down.
Right.
But if we have a module in the villages, they could still operate as a family unit.
And then you really upcycled the product that they've grown. You know, I was
Yeah.
talking about just decorticating and selling good fiber and hurd, but if you could take it to the next level and actually produce, you know, construction materials, panels, roofing panels, or wallboard or whatever, now you've got a real upsell on what you've grown.
Yeah, that's right. So, you know, I mean, we should do away with this thing called currency, you know. It's, if we can go back to the days of barter trading, you know, I think we'll solve a lot of our own problems.
Yeah.
Yeah.
Definitely. Well, was there anything else you wanted to touch on before we wrap up here today?
Well, I guess, yeah, it's really to touch on the hearts of people listening in, to get them to understand that, you know, we can do business differently. And that's what we advocate in our social impact model, is that if we look at, you know, how to solve this problem of poverty through business, not through charity. Charity doesn't always work, but by creating businesses which would enable the poor, you know, to generate income for ourselves and for themselves as well. I think we will, you know, help to contribute, you know, a little bit better to the way things are going. You know, the poor will always be there, you know, as the good book says, but we have an opportunity to do something about it. And if we treat them, you know, they have the same aspirations as we do. They want their kids to go to school. They want their kids to have good jobs. They want a proper house. They want nice things to wear. Well, if we just handle our business a little bit differently, I think we can help everybody come to some kind of minimum decent standard of living, you know, which I think is very much their right to have. So that's, I guess, the message I'd like to get across to everybody. We can get investors on board. We can get, you know, equity firms involved in this program. And of course, we can get everybody, you know, in between, from property developers and building materials manufacturers, and governments have to be involved because they own the land, right? So they've got to allocate their resources wisely to help us deal with this pandemic situation. And hopefully, you know, with more people on board, like yourselves, we're really happy to be a part of your family now.
Welcome.
You know, and really, it's a wonderful thing that you're doing to get this very important message out there. So
Yeah,
thank you. Thank you very
really
much.
Touched on the root of everything that we talk about when we talk about sustainability. Because if it doesn't make financial sense and sense on the health of people, as well as the, you know, the protection of the environment, if those things aren't all lined up, it's not actually sustainable. And, you know, the one thing that's being neglected is the thing that's going to cause it to fail. So we really do need to take that holistic look and find solutions that work for everyone as well as the planet. And, you know, everybody can make a decent living and move forward.
Yeah.
Yeah.
That's right.
Great.
Love the world. Love thy neighbor.
Absolutely. Thank you so much for your time today.
Yeah.
We really
Thank
look
you.
forward to working with you a lot in the future.
Thank you very much. Yeah.
Let's wrap it up by saying, you know, that when we do work together, we really can shape a world that works. Thanks, everybody.
Amen to that, brother.
All right.
Thank you so much, Scott.
You're very welcome. Thank you.
Yeah.
Thank you for listening to Sustainability Now. Visit sustainabilitynow.global to find resources related to today's program. While you're there, pledge your support by making a contribution to help us shape a world that works. And remember to subscribe, share, and follow us on social media.